Welcome to session 2 on drilling on the lathe. And we're going to start with a little bit of history, then move on to a little bit of mechanical engineering to give you some sense of what is behind about safely drilling on the lathe. The first bit of history is in 1860. Stephen A. Morse invented the twist drill bit. It revolutionized drilling. But there was a problem. It was very difficult and time consuming to change bits or to change sizes of the bits you were using to drill a hole. So he continued to work on it, and in 1864 he patented the Morse Taper. Now what he realized is that if you take a piece of metal, a shank, and inside that shank you mill a perfect surface at an angle, and then come to the shank, and on the shank what you do is you mill it so that it is a perfect complement. Okay? And on the shank, as they came together inside there, that marriage of those two surfaces, as they've come together, had a tremendous ability to resist rotational forces. Now you stop and think a minute for what's happening. Is you can take a 50, 60-pound green blank, put it on your lathe, get your drive center up there, and you put it up there, you bring up the tailstock, and you go at it, and that thing's going around 500, 600 RPM. You're cutting at that wood with a 5/8 inch bowl gouge. I mean, there's a tremendous amount of rotational forces that have to be resisted by this. And yet, as long as that marriage is intact, it happens, and it's great, and it's marvelous. But, and it's the but that's important, if you come into this socket and you put a little ding in it, something that holds these two surfaces apart, guess what happened? Now we've had a corrupted marriage. So instead of resisting the forces, the one stays this way and the other one turns. And when that happens, you end up with your drill bit remaining stuck in the wood and turning with the wood rather than being held firmly in the tailstock. And so you end up with a bit that looks like this as that goes flying off into the air. I tell you guys, it's scary. We really don't want that to happen. But it happened all because of this little flaw in the mating of those two surfaces. Now that's critical for us. So the first thing we're going to do in this step of looking at the key components of drilling on the lathe is to bring up our chucks, and we're going to look at them. And if I look at this one, what I see really quickly is a whole bunch of dings. Now those dings happened because I had a very poor habit of storing my chucks in a drawer, and I open and close the drawer and they run into each other. So I ended up with a bunch of shanks that looked like this, which is really dangerous. Now, it's pretty easy to resolve that. Instead of just throwing them in a drawer and bang, 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 just simply take a piece of plywood, drill some holes in it, store them like that, and all of a sudden that problem goes away. But nevertheless, that shank is really an accident waiting to happen. The second type of thing that you see is sometimes you will see shanks that look like this. Now here what we have is scoring. It goes all the way around the shank, and that's happened because the shank has rotated inside the socket of the quill in the tailstock, and it has made marks on that. And again, you got the same problem, is now we've compromised the marriage. So the question is, if you have that, what do you do? Well, the first thing you do is realize that that's dangerous. It's guaranteed to cause you a problem. So we're going to see if we can't replace it. And this is rather amazing to me, is that if I take that chuck, open the jaws all the way up, and look down in the center, what I see is a dimple. So I'm going to take a punch, put in that dimple, boom. Just that simply, we can remove that damaged shank. Now, with that removed, the next thing we ask ourselves is, how am I going to replace it? Well, we're going to look at it very carefully. And what I'm going to see, let's get you a little closer here. What I'm going to see on that is I'm going to see a JT33. Well, that JT33 means that this is the JT portion, and that's JT33 portion. So what I want is I want a replacement shank that is a MT2 JT33, which is what I have here. Find them on the internet, about 10 bucks a piece. This whole thing is about 35, so it makes sense cost-wise to actually just go ahead and replace it, replace the shank and replace the whole drill chuck. We simply put it in there, give it a tap, it's firmly seated. I mean, it's just amazing. A little tap will take it out, a little tap will put it back in, and yet in the meantime, it will resist tremendous, tremendous forces. So that's one part of the things that we need to be careful about and to make sure that we have, okay, with the shanks of our tools examined, let's move on to the next part, which is here. Actually looking at our quill on the headstock and the tailstock. Now what I'm going to do is I'm going to come in, I'm going to take my finger, I'm going to put it inside the socket, and I do this every time. Before I put anything into a socket, I'm going to take my finger, make sure there's no obstructions in there, there's no finishes built up in there, there's no gunk, there's no dust, because even dust in a socket with the forces involved will over a period of time cause damage to your quill and corrupt the marriage and give you a problem. All right, now part of the maintenance of a lathe should be to clean this, so let's just do that real quick. What I have here is what's called a Morse Taper cleaner, or more commonly the green thingy. And I'm going to take a paper towel, I'm going to take some naphtha or mineral spirits, something to dissolve any buildup tree sap or finishes in there. I'm going to moisten the paper towel, put it into the socket, turn it around, and I'm going to do that until that paper towel comes out clean. Now this is a clean socket, but you know, actually I do see a little bit of black in there, so I'm going to turn this over and I'm going to do it a second time. Okay, so at this point I've done two things. Now we're good. I've checked for any damage inside with my finger, and I've cleaned it. Now, if you do find something suspicious in there with your finger, the next thing to do is to look at an article by Leon Olson, an American woodturner, that talks how to ream out your quills if need be. Now, this is some danger in here, so be careful. What these are reamers. They're not really expensive. There's a coarse and a fine, and they're an MT2. So in effect, if you find high spots in there, what you can do is you can put those in there, rotate them by hand, and cut down those high spots so your marriage is back and the surface is made up again. One of the things that helps you make a determination whether you should go to the trouble to ream or not is this what's called machinist bluing. This particular one is steel blue layout fluid. And the way you use that is you take that, coat the shank with the bluing, put it inside, turn it just a bit, and it'll show you a mark any place. The blue will be gone any place that there's a high spot in there. So that gives you some idea. Now again, I want to warn everyone that you can ruin a very expensive piece of machinery by reaming improperly. Please, please see the article by Leon Olson, an American woodturner, before you attempt to do that. But now what we've done is we've checked the cleanliness of our headstock. We're going to do the same thing on the tailstock. Okay, now we have to make a decision about what type of drill chuck to use, and they come in all sorts of various sizes. I mean, this is probably the most common size out there. Find it all over the place. This one, but it's a keyed type of chuck. This one is no key. You can just do it by hand, which is advantageous. You got one less little thing to worry about. This is, again, a keyed chuck. This is a behemoth. This is 3/4 inch drill chuck. I mean, this thing weighs like 2.5 pounds. I mean, it's really heavy. This is one I had to come across that I really like. It's a 3/8 inch, drill chuck. And again, you don't need the chuck, you can just turn it, holds it fine. The interesting thing is, this is a 1/2 inch. This is the most typical one we find out there. This is a 1/2 inch. But really, almost all the bits we use are 3/8. So this one works quite fine. This is my favorite. This is the one that I use, which is no longer available, so I really can't talk about it too much. But what I really liked about it is this part, the shank goes into the tailstock quill like that. So I have the support of the tailstock very close to the cutting edge of my drill bit. And that's a real advantage, because you have to realize it's the old child's game where they all get in the line and they hold hands, and then the first one starts to move around the playground, and the one at the end, he's running so fast he can't keep up. Well, the same thing happens in drilling. Any kind of give in your tailstock or your ways or in your drill chuck, you take a little bit of thing back here, by the time it gets to the cutting edge, it's a big swing. So the shorter I am between the support of the tailstock and the cutting edge, the truer I will be able to drill. One that's fairly similar that is available, this is by Carter Products. This one has various extensions that you can add to it to make it quite long. It's both threaded. These two are threaded together. They're also set screws. It's a good product. I'd look at it quite carefully if I was looking for a replacement system. However, I have a problem with it, is that my drill bits, my very expensive Colt MaxiCut drill bits, won't fit into it. This particular one is one made by Woodcut. It's actually called a mill drill. And what it is designed to do is, when you make pepper mills, to actually make 2 cuts at the same time to speed up, make that whole process more efficient. It's a good system. It also has a drill bit holder, because again, a lot of support, and shortens the distance between the cutting edge and the support of the tailstock. Now, if I had to take my choice, what would I use? I'd use this one. Why? Because of the distance, the shortest, and it goes directly into the tailstock. This one works, the Carter product one works, the stout bore system, but it's a little longer than I would really like to have. This one is my go-to very frequently for shallow holes. It's just quick, easy, and again, it's a short distance, lots of support. This one I would not use. It's just too big. It won't stop moving when I need it to, and I'm too far away from the support of the tailstock. Now, a lot of difference of opinions. No one is totally right or totally wrong, but the important thing is that you think about why you're using the drill chuck that you're using. In my world, what my belief is the critical thing is the distance of support from the cutting edge to the tailstock. Now, I want to take a minute and talk about this one. We see sometimes this type of a twist drill bit out there. It has the benefit if it goes directly into the tailstock, but I was always kind of nervous about using it, and I couldn't figure out why until I looked very, very carefully. And what I found is, and let's see if this shows up well or not. If I look at the very tip, there's not a point. That's over a 1/4 inch flat on here. So I would suggest to you that this type of configuration, when you go into the wood, would make it want to wander pretty badly. And this is perhaps a dangerous type of bit because of the configuration of the milling right in here. That would be on my least favorite list. Okay, now we've kind of talked about the scroll chucks and some of the choices you have. The next thing I want to talk about is speed. Right up here by my lathe on a bulletin board is a chart that has the various sizes of drill bits and whether it's a hardwood or softwood and what the RPM maximum should be. Now, the key thing is that drilling with a Forstner bit really is a slow speed operation. You need to get the RPMs down. Now, this chart is going to suggest that the RPMs ought to be someplace between 400 and 900. On a smaller diameter, it's going to be up closer to the 900. On the larger diameter bits, it's going to be more like 400. It's better to have the RPMs a little low than it is to have them high. If you get them high, you're just asking for overheating problems and problems. Now, again, as I mentioned in the first session, if you find that you have a tendency to want to turn up the speed, it's a sign your drill bit is dull. Go back and sharpen your drill bit. If you find that you want to crank harder and harder to crank on that tailstock handle, to assign your drill bit is dull. So go back and sharpen your bits as the first thing. So what we've covered so far is how to sharpen your drill bit. We've covered about how to maintain your headstock quill, your tailstock quill, how to examine your shanks, how to replace a shank that's damaged. All these little things make drilling go easily. You mess up on any one of the little things, it can really trip you up. If this has been worthwhile to you, please give me a thumbs up and hang around for the third session.